Hi, Rohan. How are you doing?
I'm doing good, sir. How are you?
Very good, very good. So last time I introduced you to trigonometry. Do you understand what we talked about?
Yes, sir. I started to get a grasp on the acronyms SOHCAHTOA, sine,
Mhm.
cosine, and tangent, and
Mhm.
being able to learn their formulas.
Okay. So we'll see what you have learned, and then from then, and then we'll begin from there. Is that okay? Let me share with you the lesson for today. So we talked about these things. Basically, this is a summary of what we learned. Things to remember. Can you please read what is written here?
Sine, cosine, and tan are considered primary trigonometric ratios.
Yeah, so that is theta. So sine theta, theta is a Greek symbol like alpha, beta, gamma, theta. We'll be using these Greek symbols a lot in trigonometry. Okay. So sine theta, cos theta, and tan theta are primary trigonometric ratios. And notice that sine, cosine, and tangent, that's their full name, written in short as shown here. They're always with lowercase, right? Not capital S, lowercase, correct? The other three which are mentioned are cosecant theta, secant theta, cotangent theta. They are called secondary trigonometric ratios, right? So the primary trigonometric ratios, we understood sine, and to remember what sine really is, we have an acronym here, SOHCAHTOA. Sine is the ratio of opposite to hypotenuse, correct? So in a particular triangle, as you can see it here very clearly, the side which is opposite to the angle. So if this is angle theta, in that case, that is the side which is opposite, and ratio of that side to the hypotenuse is sine theta. Is this clear to you?
Yes, sir.
Whenever in a question you are given opposite side or hypotenuse and you have to find something else with the angle, then you know you have to use sine theta. Cosine theta is the ratio of adjacent side, which is between the angle of interest, which is theta, and 90 degrees. We are always working with a right triangle. Is that okay? Always a right triangle we will be talking about, right? There are general examples on any angle. We'll do it later. But for now, all these ratios, we are working on right triangle. So cosecant theta, secant theta, and cotangent theta are the secondary trigonometric ratio. They are actually reciprocal of primary trigonometric ratios. You could also call them reciprocal ratios. Reciprocal ratios mean 1 over sine theta. So as I've written here, what is cosecant theta? Cosecant theta is the reciprocal of sine theta. It is 1 over sine theta. Correct? So basically, that will be hypotenuse over the opposite side. Is that clear? So this will be basically hypotenuse over the opposite side. Is that clear? Reciprocal.
Also, basically, the opposite, right, sir? Like, in
Reciprocal.
fractions from division,
Yes,
you just like switch numerator and denominator.
correct. Reciprocal. We call not really opposite because sometimes you say plus and minus are opposite, multiplication and division are opposite, but we'll call this as reciprocal, right? So we'll use this word, reciprocal ratio or secondary trigonometric ratios. Secant theta is reciprocal of cos theta, and therefore it is going to be what? It is going to be equal to the hypotenuse over the adjacent side. Clear? Third reciprocal ratio is cotangent theta, which is reciprocal of tangent theta. So tan is opposite over adjacent. This will be adjacent over the opposite side. So these ratios are also frequently used. Perfect. Secondary trigonometric ratios are reciprocal of primary ratios. Clear? Trigonometric ratios have no units because they are measurement of one length over the other. So the length units will cancel away. They are just the ratios, correct? All trigonometric ratios are written in lowercase. Greek symbols alpha, beta, gamma, theta, delta is the next one, are commonly used for angles. There are many others, like phi also we use commonly. So we call this as phi. That is also very commonly used, right? So these are the Greek alphabets. Mnemonic to remember. Primary trigonometric ratio is SOHCAHTOA, or as I write, sine as ratio of opposite to hypotenuse, cosine as adjacent over hypotenuse, and tan as opposite over adjacent. Okay, so these are the ratios. I thought I'll take you for a tour on my nature visit, and there we'll take up an example, a shot which I took a couple of years back, and we'll try to understand how does trigonometry really help us in doing or understanding our position. Is that okay? So I'll just stop this for now and share with you a YouTube channel video with you. Okay, so let me see if I can get hold of that. Not okay. It's not coming. I don't know how. Okay, you share it. You run it on your computer and then share this particular link.
All right, sir. I'm just gonna share my screen, sir.
Yeah. Okay, so can you read this question, please?
Wait. I saw a pair of Canadian geese ready to fly at an angle of depression of 30 degrees from the height of 3 meters. They look off
Took
and
off.
flew just over, they took off and flew just over 3 meters above me as shown in the video. Estimate my distance from the geese.
Okay, so let's try to understand this particular question, and then we'll see the video, and you may help me answer this question. Okay, so what I'm trying to say here is, let us say that's a bridge on which I'm standing, right? And the geese actually flew 3 meters above me, right? So that is the position. And what I'm trying to say is this angle of depression. So let's try to understand what is angle of depression. So if I angle of depression, if I make this horizontal line, then from horizontal it is 30 degrees. That is what angle of depression is. So from any position horizontal, what is down, right? So going down from that horizontal position gives you the angle of depression. So that is 30 degrees given to us. So at an angle of depression of 30 degrees from the height of 3 meters. So I saw a pair of Canadian geese ready to fly at an angle of depression of 30 degrees from a height of 3 meters, means this height is 3 meters for me. I'm standing on this particular bridge, and from that height, I'm watching these. And that is the geese. Is that clear to you?
All right, sir.
Now, what will be this angle? Can you tell me?
I think that would have to be 30 degrees, sir.
Yes, because these are parallel lines, so that has to be 30 degrees. So when we talk about angle of depression, if you see from the geese angle, that becomes the angle of elevation. So these are the two terms which are frequently used. Is it okay?
All right, sir.
And the type of question which you are trying to do now is a height and distance question, correct? So we'll classify this as height and distance question. So we know the height at which we are there, right? And we know the angle, but we really want to find the distance. So it says, estimate my distance from the geese. That means, are we interested in this distance or the hypotenuse?
We're interested in the hypotenuse, sir.
Correct. So we are interested in the hypotenuse. We know the opposite side. How do we get, which trigonometric ratio should I use to find the hypotenuse? Can you tell me?
I think tangent, sir.
No, because we know opposite side and we are interested in hypotenuse. So which one
Also,
relates?
then sine.
Sine, because sine gives you this ratio. That is how SOHCAHTOA helps you. Get the idea now?
All right, sir.
Which ratio to be used when? Perfect. And then you can calculate the value for this particular example. Is this clear to you? Correct?
Okay, sir.
You will also notice that in the question, I have given you some values which are kind of exact values. So when I write values, they are not in decimal, right? So it's called exact values. So sometimes we'll say, solve this question and write your answer exactly. That's what it is. Is it okay? I'll
Okay,
also
sir.
tell you how do we get exact values. So that means this is without calculator. Now you've been used to, you just started. So therefore, you see all the, you use calculator to find the angles. But there are some special triangles which I'm going to introduce to you. They will help you to answer this question. Okay. Now, we'll answer this question later. Can you continue and see the picture?
Okay, sir.
Run the video. You see these two geese, right?
Yes, sir.
This was taken in Humber Trail. So I'm just standing there over the bridge and, they're making sound. So I know it's an alarm for them to now take off and fly away, right? So they are always in groups. So because of that, I knew they are going to fly and the direction was very clear. They're coming towards me. There you go.
Okay.
So they went over me. Do you get the idea?
Yes,
So,
sir.
so they went just over me. And therefore, that question, now you understand the sketch, right?
Yeah.
You can pause the video. We are going to answer this question later. Perfect.
All right.
Once again, I'll now share my screen. You get an idea. How do we solve this, correct?
Okay, sir.
The only thing you want to learn now is how do we do without calculator, correct?
Yeah.
Perfect. So let me share with you my screen now. Perfect. So we now understand that these primary trigonometric ratios are sine, cosine, and tangent. And in a right triangle, they are ratios of two sides, right? So depending on which sides we take, we know which ratio it is. And we do have reciprocal of those ratios, so which is just the reverse, correct? Now, as we have seen that sine theta basically is a ratio in which we have hypotenuse in the denominator. Since hypotenuse is in the denominator, sine value cannot be more than 1, right?
Yeah.
Maximum it could have 1 as its value. Same is the case with cosine, correct? How about tangent? Can tangent of an angle be more than 1?
Maybe, sir.
Yes,
Because like
because
only sine and cosine can have the value of 1.
maximum 1, right? Tangent is ratio of the other two sides, which are smaller, but any one of them can be bigger. So it could be more than 1 also. So it's all real numbers as far as the tangent is concerned. Okay. So it's very important to understand. And how do we explain that sine theta is never greater than 1? And secant theta is reciprocal of cosine, right? So it is absolute value means always positive, because you'll soon learn that these sine and cosine can also have negative values. You've seen that sine curve? Sine curve is kind of like this. This is called a sinusoidal wave, right?
Yes, sir.
Now, as you can see, this wave, if I draw x-axis here, it does go negative. You see that?
Yeah.
But whatever said and done, the maximum value is 1 and the minimum value is -1. So absolute value is within 1. That's what I'm trying to say. Is it okay?
Okay.
As far as the ratio of reciprocal trigonometric ratios is concerned, for example, secant theta or cosecant theta, secant theta is the reciprocal of cos. But if I do cosecant theta, let me sketch cosecant theta here. So this is sine theta. Now I'm going to sketch cosecant theta. So that is reciprocal. What is the reciprocal of 1? 1, correct? So the and -1 will be -1. So these points will be common. However, the other and reciprocal of 0 is not defined, correct?
Yeah.
There are many terms which are difficult to understand now, but will make sense soon. So the cosecant theta graph will be kind of like this. You see that? So as you
Okay.
approach 0, it will be very high, correct? And negative side, kind of like that. So you can see that absolute value of secant theta or even cosecant theta will never be less than 1. Correct? Because if half is there, reciprocal of half is 2 over 1. Do you get the idea?
Yeah.
2 over 3, reciprocal is 3 over 2. So that has to be greater than. Perfect. So this is important to understand that sine and cosine will have maximum value as 1 and cosecant and secant will have a minimum value of 1. Is it okay?
So basically, they never touch, sir, like
They
till
touch at
0.
1. They touch at 1. 1 is common. 1 reciprocal is 1. Right? So if the angle is 90 degrees, sine theta is 1. And for that, cosecant theta is also 1. If the angle is 0, then adjacent is same as hypotenuse. And therefore, secant theta and cosecant theta will both be 1 for 0 degrees. Is that clear?
Yeah.
Now, in that particular example, I said that we could solve that question without calculator. Since these are very special triangles, which are very useful to calculate the trigonometric ratios. As you can see, we know these trigonometric ratios, sine, cosine, and tangent are ratio of the sides. Now, if the angle is, let's say, 45 degrees, that means there are two 45 degrees. It's an isosceles triangle, correct?
Yeah.
If one of the side is 1 in a right angle triangle, what will be the hypotenuse? 1 square plus 1 square square root, which is square root of 2, correct? So that clearly indicates that sine of 45 degrees is what? Opposite side over hypotenuse 1 over square root 2. Similarly, cos of 45 degrees is also 1 over square root 2. Yeah?
Yes, sir.
Right. Now, if you have an equilateral triangle, in that case, let us say that all the sides of an equilateral triangle are 2 each. If I drop a perpendicular, it is going to bisect it. So this side will be 1. What will be the height? 2 square minus 1 square square root, correct? Which is 4 minus 1, which is square root of 3. So square root of 3 is going to be the height. You get the idea?
Okay,
and the
sir.
angle will be, here we have 60 degrees and here we have 30 degrees, correct? So if I'm looking from the 60 degree side, then what is opposite to 60 degrees?
It will be square root of 3,
Square root
sir.
3, right? So you can relate these triangles. And what is opposite to 30? 1, right?
1.
So, and there you go. You have another triangle. We call it special because all these numbers are whole numbers, correct? So easily we can actually have the ratio. So what is sine of 30 degrees? Can you tell me what is sine of 30 degrees?
Sine of 30 degrees, sir.
Yeah.
It would be basically 1 over 2.
Perfect. Sine of 45 degrees?
Sine of 45 degrees would be 1 over square root of 2.
Sine of 60 degrees?
Sine of 60 degrees would be square root of 3 over 2.
Sine of 90 degrees?
Sine of 9. Which one, sir?
90 degrees will be a triangle which has, a hypotenuse same as the opposite side. So if I keep on increasing this angle, right? So then the triangle will be like this. You see that? You get 90
Yes,
degrees
sir.
here. At this moment, hypotenuse and the opposite side are same. Therefore, it is going to be 1.
Okay.
But if I put it down there, which is a 0 degree, correct? In that case, opposite side has reduced to 0, right?
Oh,
So it is 0 here. Is that clear to you? So you can
okay.
fill up these values and remember, these are the exact values of sine theta when we're talking about the angle between 0 to 90 degrees. Clear?
Yeah.
Now, as far as cos theta is concerned, for 0, the cos theta adjacent side and the hypotenuse is one and the same thing, and therefore cos theta has to be 1. What is the cos of 30 degrees? Adjacent side over hypotenuse, correct? So it is square root of
Yes,
3
that's good.
over 2, as 45 degrees is same as sine, which is 1 over square root 2. And for 60 degrees, adjacent is 1. So now it is half. And for 90 degrees, it is 0 because now the adjacent side has been reduced to 0, correct?
Okay, sir.
You get an idea. Similarly, you can fill up tan theta and their reciprocals. So let this be your homework. Try to fill it up. What you notice here that in the quadrant one, this we say quadrant one, everything is positive. When we are moving from 0 to 90 degrees, the sine value is always increasing, correct? From 0 to
Yeah.
1. And cos is decreasing from 1 to 0, correct?
Okay.
Right. That is kind of, it is kind of obvious because if I have a circle, if I have a point moving on a circle, let's just take up this example here. So let us say that is a coordinate plane, right? And we have a circle here, right? And then if I have a point which is moving, right? If I move the point, which is the value of p of xy, correct? Let's say circle has a radius of r. In that case, what is sine theta? Making an angle.
Science.
Height will be y value, correct? Y over r.
Okay.
And the cos theta will be x over r, the x value. Is that okay? This distance.
Yes, sir.
Is that clear? So with the
Yeah.
coordinate point, we can find both sine and cosine. Do you see that? Now, if I am moving in this direction, you see the opposite side is increasing.
Yes, sir.
So from 0 to 90, this is increasing. Do you see that?
Yeah.
But the adjacent side is decreasing, right? As you move, the adjacent side shrinks. Do you see that?
Yeah.
So that is decreasing to 0 from 1 to 0. Get the idea?
Yes, sir.
Picture gives you a
Okay.
good idea of how the things are changing. Correct? Okay?
Yeah.
So let's move on. Now, actually, you can answer that Gee's question. The angle of elevation was 30 degrees, correct? What was the height for us?
3 meters, sir.
3 meters. So instead of 1, it was 3 meters. Just a question of ratios, right? So for 30 degrees, we're looking into sine. Is that okay?
Yes, sir.
So with 30 degrees, if it was 1, the hypotenuse was 2, correct?
Okay.
But it was, if it is 3, it will be 6 meters. 6. You get it?
Yeah. So basically, there's an increase.
A ratio. It's just a ratio, right? So
Yeah.
in the Gee's example, I'm standing at a height of 3 meters, right? So I'll assume this to be 3, correct?
Mm-hmm.
So if I make it times 3, then everything gets times 3, right?
Okay.
So the distance from myself to the Gee's, that as we see, line of sight, will be 6 meters. You get the idea now? How
Yes,
easy
sir.
it is? So from the ratio, we just solved it because now we know this special triangle, 30, 60, 90. We call this as 30, 60, 90 triangle.
Okay.
Got it?
Yeah.
Even otherwise, you could solve it. So I'd like you to watch the video further and see what is the other way of solving, correct?
Okay, sir.
Using sine ratio. Perfect. Now let's move on with our second example. Can you please read this question?
Given triangle PQR, PQ equals to 8 centimeters, QR equals to 6 centimeters,
Mhm.
and angle PQR is 90 degrees.
Oh, that is
Write the
interesting.
6 trigonometric ratios in lowest terms of angle P.
Yeah.
So, and that's it, Richard? Or do you
Yeah.
want me to read?
That's it. So how will you find for sine theta?
Sine theta?
Let me
Yes,
write
sir.
sine p. Yeah.
So basically opposite over hypotenuse. So
Yeah. You have to
height.
calculate hypotenuse, right?
Yeah, okay, sir.
So you'll calculate hypotenuse as shown here, this square plus that square root, right? And you get the number 10. So you get hypotenuse of 10. Well, when we are working with right angle triangles, it is very important to remember some right angle triangles, right? We call them triples.
Okay.
Like 3, 4, 5 is a triple. If the two sides are 3 and 4, then the hypotenuse will be 5. You know that?
Yes, sir.
You know it, right? So it is like 9 plus 16, which is 25, correct? And the square root of 25 is 5. Now, this side is twice 3, 4, 5, right? Instead of 3, it is 6. Instead of 4, it is 8. And hypotenuse will be 2 times 5, which is 10. So
Okay.
this triangle is very easy. So as soon as you see the triangle, you know hypotenuse is 10. Of course, you can always calculate. I'm not saying that you cannot calculate. You can always calculate. But immediately also you can come to the result. You get the idea?
Yes, sir.
Now tell me what is sine of p?
Sine of p, sir.
Yeah.
So then it would just be 6/10, sir,
And
which is
then
equivalent to 3/5.
that is what you'll write your answer. Now you can write all the trigonometric ratios just to practice. How do we write primary and secondary trigonometric ratios? Simplify one set and then flip them. That is reciprocal to get your secondary trigonometric ratios. Correct?
All right, sir.
Okay. Now let's take example number 2. Okay. So in this example, write 6 trigonometric ratios for angle R. So this time we'll write from this side. That is the only difference. Earlier we did it from P, right? So you'll notice that
Yeah.
sine becomes cos, right? So what we'll notice here is that the sine P will now be equal to cos R.
Cos R.
Why? Because what is sine P? Let's say what is sine P? Sine P will be 6/10, correct? And
Right,
what
sir.
is cos R? Cos R is also 6/10. Of course, you'll simplify. So both are same. Do you understand? 90
Yeah.
minus theta. So because for the cos, it is this, and for the sine, it is opposite side. So when it is 90 minus theta, in that case, sine becomes cos and cos becomes sine. Tan becomes cotangent, cotangent becomes tangent. They are equivalent. Is that clear?
Okay.
So it's a very important step. We call this as cofunction identity. So the cofunction identity is that sine of 90 minus theta is cos theta, cos of 90 minus theta is sine theta, tan of 90 minus theta is tan theta. Since clearly, when we have a right angle triangle, then in that case, angle R is equal to what? A is equal to 90 degrees minus angle P, correct? That's what we mean when we say
Okay.
90 minus theta. Is that clear to you?
Yes, sir.
So these are cofunction identities. You could derive this result from the previous one and match, right? How do they match? Is that okay?
All right, sir.
So I hope you have understood these primary and trigonometric ratios and how do we work with them. Let me take up another question now, which says, what is the value of tan 90 minus theta into tan theta? Tell me. What is tan
And
90?
90.
So this is the angle theta. We have not given you anything, but we're just asking, what should it be? Tan 90 minus theta into tan theta should be what?
It should be opposite over adjacent, sir.
Okay,
So
let's say opposite over adjacent. This is 90 minus theta. You're looking from, okay, so this is tan theta, right? So you did this first, correct?
yes, sir.
And then let me write the other way. First, look from this side. So if you like, what is the opposite from here? Is actually
Could be
adjacent, isn't it?
adjacent.
Over
Yeah.
opposite times tan theta. If you look from here, it is opposite over adjacent. So they cancel away and we get 1. Do you get the idea?
Yeah.
Or even otherwise, tan 90 minus theta will be reciprocal of that is cotangent theta, right? So we could write, let me rewrite this as cot theta, right? Times tan theta. Now they are reciprocal ratios, correct? Cot theta is 1 over tan theta. And therefore that should be equal to 1. Get the idea?
Okay, sir.
Because cot theta is 1 over tan theta, correct?
All right. So basically, we're just doing like the confusion identities again, sir, right?
Cofunction identity. It's an
Like
application
cofunction
of
identity.
cofunction identity. So these are called cofunction, right?
Yeah.
Cofunction. We use instead of one, the other one when the angle is 90 minus theta. Okay. Very important result. So that's why I took it up. Now let's take another example. In this example, what we are doing is we have a right angle triangle, but we are saying secant A is 13 over 12. You understand what is secant A? Secant is the reciprocal of cosine. Is it okay?
Okay.
So secant will be what? Secant A
So
will be
height
hypotenuse
over.
over adjacent. Is that okay?
All right.
So when we say given secant A is 13 over 12. That means if you make a right angle triangle, you can write 13 for the hypotenuse and 12 for the adjacent side and for the angle A. Is that clear to you?
Yes, sir.
Once you know these two sides, you can find the third side using Pythagorean identity. Correct?
Yeah.
So 13 square minus 12 square, square root, will give us 5 as the result. And so we have 5 there as BC. Perfect?
Oh,
Once you
because
know
like
three
square
sides.
root of 25 is just 5, sir. Okay.
Pardon? Oh, sorry. This should be what? 13 square minus 12 square, right? Yeah.
Yeah.
13 square minus 12 square, right? You can do 169 minus 144, correct?
Yeah.
Which will be 25 square root, which will be 5. Is it clear?
Yeah.
So this is also a triple, Pythagorean triple, so we can easily know that this will be the side. Perfect.
All right.
So you watch my videos on Pythagorean triple, you will understand how do we know or remember that these are the triples. You see there's one difference between 12 and 13, right? You see that?
Yeah.
So, so that formula is given and that helps you to find the ratios, all the many triples. So watch my video on that, okay?
All
Now,
right.
once you solve your triangle with the sides, then you can easily write down all the trigonometric ratios, primary as well as secondary, correct?
Yeah.
No, right. See, this question is without calculator, right? So, without calculator. Well, if the calculator was allowed, you could also find the angle first and then with calculator calculate all the trigonometric ratios, right? But the fun
Yeah.
here is to use the basic definition and then write down the ratios. Clear?
Okay, sir.
Okay. Now we are coming to a very, very important question. Now this is it's a challenging question. So normally I'll give this as a student activity. It says, prove z square equals to xy. Now, z in this case, we have a right angle. Now, let me just explain you this particular triangle. ABC is a right angle triangle
Yeah.
with 90 degrees at B. And on this triangle, B to D is perpendicular to the hypotenuse AC. You see that?
Which one? Because there's like
BD,
two capital C's, sir.
BD. Well, that should
Mhm.
have been, yeah, that should have been lower C because side, right?
Yeah.
Opposite to C, lowercase c will be the length of AB.
Okay.
Right. B to D is perpendicular to AC, which is the hypotenuse. And what we need to show here is that this altitude is equal to product of these two sides. You get the idea?
Wait, sir, I'm lost.
You have to prove that this length is square of this length is product of x and y.
So basically Z square for
Yes,
X and
x.
Y.
Yes. So we say z square equals to xy, or we could say z is equals to square root of xy. And this is called geometric mean. This is called geometric mean. Because geometry is product, correct? So mean is
Yeah.
just multiply them and then do square. You know what is arithmetic mean?
No, sir.
A plus B, if there are two numbers, arithmetic mean is divide by 2, average. So we have
Okay.
some questions based on geometric mean and arithmetic mean. So arithmetic mean is just add the numbers, divide by 2. Geometric mean means multiply square root. Is that clear to you?
Okay.
So that is what we are going to show here, that this length is the geometric mean of the other two sides. So sometimes we put it the other way. We make a triangle like this. So what I'm doing here is making a right angle triangle where the right angle is here. Do you see this?
Yes, sir.
And then we'll drop a perpendicular from here. Let me use a different color. So we'll drop a perpendicular from here. and say this length is z, it cuts into two pieces, x and y. So we are saying z is equal to geometric mean of x and y. And that is true in any triangle, in any right angle triangle. Okay?
Yes, sir.
Now we are going to prove this with the help of the trigonometry, which you have to learn. It's a very important theorem, but you will soon see how easily we can prove it. You remember we said tan theta times tan 90 minus theta is 1?
Yes, sir. So basically, we have to do the opposite.
Yeah,
So
tan times
opposite
tan
over adjacent is
cotangent theta
adjacent
is 1.
over opposite.
That can help you to prove this, correct? So how will you do? Can you give me some hint? What do you think? How should we approach?
I think first, sir, we would just have to, because by looking at the equation, sir, I think we need to do the cofunction identity.
Mm-hmm.
So basically, sine, which would be by looking to the term. I think Z may be this tangent, sir, right? So then we would just like use opposite over adjacent as adjacent over opposite to just cross them out to get 1.
Okay. So there are three right angles here. Do you see that? ABC is a right angle triangle. ADB is also a right angle triangle, correct? Because
Yeah.
perpendicular. And similarly, another right angle triangle is here. Do you see that? There are three right angle triangles, big one and the two small ones.
Okay.
Right? So we could use the properties and then get to the result. What is sine alpha equals to? Sine alpha, if I break this angle into alpha and beta, sine alpha will be x over z. We are trying to figure out which ratios are relating x, y, z, correct?
Yeah.
So if you see x and z with alpha, right? So we say tan alpha could be equal to what? X over z, right? Correct?
Yes, sir.
Now, if this is 90 degrees, beta is 90 minus alpha, right?
Yeah.
What is tan beta equals to? If you look from beta, what is tan beta equals to? The opposite side is y and adjacent is z, right?
Z.
Y over z. Now their product is what? 1, correct?
Yeah.
Because beta is 90 minus
90.
alpha, correct?
Yeah.
So if I multiply, what do I get? X
You would
over
get,
z times y over z, right? That should be equal to 1, correct? Because
yeah.
that is 90 degrees. And directly we get x times y is equal to z squared. Do you see in 3 steps we have proved this particular theorem? You get the idea.
Yes.
This theorem can also be proved using similar triangles. Because as you have seen, there are 2 or 3 right angle triangles here, correct? So alternate method is to use similar triangles. That will take half a page. If you use similar triangles, first you prove these two triangles are similar, then you find their ratios, right? Of the
Yeah.
sides must be constant, same. Then you multiply and get the result. But here, simple tan alpha is x over z, tan beta is y over z, and their product has to be 1, right? And if you multiply these, you get x over z times y over z equals to 1, and therefore xy is equals to z squared. Perfect. Do you understand this proof?
Yes, sir. I was able to like understand more about the co-function identities
Yeah,
and how
very
to
important.
use it.
Let's see the clear proof for this. So we wanted to prove in this particular case that z square is xy. That is also called a geometric mean concept. We know that angle beta is equal to 90 minus alpha, right? Because that is the right angle. The other angle is alpha. So we just broke 90 into alpha plus beta, right? So we wrote 90 degrees as equal to alpha plus beta, right? So beta is 90 minus alpha. Rohan, that tan alpha is x over z, tan beta is y over z. The ratios, as you know, opposite over adjacent. When we multiply them, we should get 1, since we know that beta is 90 minus alpha, right?
Yeah.
And as soon as you multiply x over z times y over z, we get 1, and xy is equal to z squared.
All right, sir.
That is how we
Sir,
approach.
so basically, the most common like type of Greek symbol which we would use would be theta, right, sir?
Theta, yeah, always, yes.
Alright.
And other angles, we have used alpha, beta, and also phi here. Do you see the symbols for phi?
Oh, okay.
Okay. Yeah. But you can always call the angle with the vertex name, like this will be angle C, right? It becomes complicated because if I say angle B, I'm not sure which angle I'm talking about. Is it alpha or beta, right? Or both, correct?
Yes, sir.
So therefore, we'll have to say angle ABD or something like this. It's better to write alpha, beta there, correct? It helps.
Yeah.
Now, here is a question for you. Can you please read this question?
Avav is flying a kite which is above the house of Akshit.
Mhm.
Horizontal distance between Avav and Akshit's house is 500 meters. Find the length of string if the kite is flying at an angle of elevation of 60 degrees.
Perfect. Angle of elevation is taken from horizontal to what you see above. Do you see that? So in this
Yes.
particular case, we have Abhinav is flying a kite which is just over the house of Akshat. So that is the kite as shown here, which is over the house of Akshat. So Akshat is here. Is that okay? So that point is Akshat. So we can say this is A, for example, Akshat, A. And Abhinav, I've written as T. So, and this is the kite. Now, horizontal distance between their houses 500. That means this distance is 500. You see that? So it's
Yes,
very
sir.
important to make the drawings correctly, especially when it comes to 3D. So we have this example, which is a 3D height and distance problem, right? Now,
Okay.
yeah. So now we have an angle and the kite. We need to find the length of the string, which is this length, right? So which trigonometric ratio will you use?
Sir, I think I would use tangent personally.
Why?
Wait, just give me.
This says Abhinav is flying a kite which is just over the house of Akshat. Horizontal distance is 500 meters. Find the length of the string when the angle is 60 degrees. So we are given this angle
Oh,
here as 60 degrees, right?
no,
We are
better.
interested
Like,
in these two sides, right? On a right angle
yes,
triangle. So which ratio will you use from SOHCAHTOA?
cosine, sir.
You are right. So this is wrong. This is right. Do you understand? So that is what you have to see. When you have formed a right angle triangle, you have to see the sides of our interest. So clearly, here it is cos of 60 degrees will give us the solution, which is the length 500 over unknown x, correct? Cos of 60 degrees is also known to us from the special triangle. What is the value of cos of 60 degree from this special triangle? Can you tell me?
The cos is 60 degrees, sir.
Yeah, from this special triangle, 30, 60, 90. Cos is adjacent to hypotenuse, correct? So what is the
Yes, sir.
adjacent?
The adjacent would be 1, sir, and then the height would be 2. So half,
That is
sir.
half. Correct. So now you can cross multiply, and that gives you the value of x as 500 into 2, right? Which is 1000 meters. Is this clear to you? So easily we have solved a question which relates to 3D height and distance problem. Is this clear?
It's a bit clear, sir. It's just gonna take a while to understand the 3D version.
Yeah. So here again, we have your simple calculation, which I just did. So at O, I'm showing the house of Akshat, above which this kite is there. And the angle here is 60 degrees. And we have to find X, the string length. And then we can use cosine function because we know cos is the ratio of adjacent to hypotenuse, correct? So in
Yes,
this
sir.
case, we are given adjacent side and we need to find the hypotenuse for the given angle, right? So that is how we could easily use it. Perfect. And we applied this special triangle to calculate the value of cosine. So the calculator is not really required for such questions. You see that?
Yes, sir.
Okay, we come to an end of our lesson today. So what I did here is just for your practice. Here we have three triangles. All the three are right angle triangles, correct?
Yeah.
So 4 to 6, find exact value of primary trigonometric ratios. So what you need to do here is for each one of them, you have to find what is sine of angle theta. So I mentioned angle theta. Do you see that angle theta is here?
Yeah.
In this case over here, right? Well, in this case, it is 45 degrees. So you can take theta as 45. Is it okay?
All right.
So we have to find sine of angle theta. Can you tell me what is the sine of angle theta in the first case for question number 4?
Sine of angle theta, sir.
Sine theta is how much in case 1? Question 4.
It would be x over 2x, sir.
Which is half, correct?
Which is,
In this
yeah.
case, how much it is?
In the third question,
Yes, in
it
this.
would be in the second question, it would just be x over x square root of 2, which would just be half.
And in this question,
In the third question, it would just be,
we don't know that side. So do you see the numbers 3, 4, and 5 works, right? So this has to be
yeah,
3. You can use
3x.
Pythagorean theorem to find that side. Is that okay?
Yes, sir.
X and X will cancel. And what is your answer?
So basically 3 over 5.
Easy to get. So you can actually write down all the trigonometric ratios primary and get your answer. Is that clear to you?
All right, sir.
So that will be an exercise, and still you have that video to watch and write down the answer for that particular question, which we did, correct? So I hope you understand how do we solve right angle triangle using primary or secondary trigonometric ratios. Basically,
Yes, sir.
correct? So we'll end our class here. You can actually summarize what you learned today and how useful was it. Yes. What did you learn?
So far during this class, I've started to have an understanding on secondary trigonometric ratios,
Mhm.
and then learning about how each one of them has a relation,
Mhm.
and then starting to look forward to how to solve a problem without using a calculator and
Yes.
looking at 3D models.
Very good, very good. So practice some more questions. I'll share with you some videos which will help you further. Okay. From your book also, you can do some questions. Is that clear?
Thank you,
Okay,
sir.
then. See you next time. Bye. All the best.
Bye-bye.
Bye.